Okay, a very good morning dear students. Welcome to my channel Maths with Mahanti sir. Children, in the previous lesson we were discussing about your algebraic expressions, okay, where we discussed everything in detail. The last part of the chapter was your factorization of algebraic expression, how it is done by three methods I discussed. By taking HCF as a common factor, the first method to factorize algebraic expression. The second method is what? By taking binomial as a common factor, how to factorize, that I had discussed. Then by regrouping of terms, how to factorize algebraic expression, okay. Everything, particularly in class 7 algebraic expressions, we read what? We read about how to multiply algebraic expressions, how to verify the product, then how to factorize algebraic expressions, which will help you in class 8 and 9 and 10 etc. to a great extent, okay. So also we have completed the chapter linear equation in one variable earlier as given in your syllabus, that is your book, NCERT syllabus or DAV book, whatever you say. So today we are going to start a new chapter, that is your properties of triangle, okay, or triangle and its properties. See children, in this chapter what are the areas we will discuss, what is the scope of this chapter. In this chapter we will discuss mainly about isosceles triangle, what are properties of isosceles triangle, then your exterior and interior angles, exterior angle, interior opposite angles, what is the relation between them, and there are so many things. This is a very big chapter. So let us discuss, okay, one by one. So first let us discuss what are the properties of isosceles triangle. Children, you know, I hope you know what is isosceles triangle. See, this is a triangle. If two sides are equal, see, suppose ABC is a triangle and the length of any two sides, either AB equal to AC or AB equal to BC or AC equal to BC. If the length of any two sides equal, then it is called an isosceles triangle. We know it from class 5. Now children, the point is, if I ask you, see, these two sides are equal, okay, so it is isosceles. Now if I ask you, which is the opposite angle of the side AC, you can easily say, sir, it is angle B. If I ask you, which is the opposite angle of this side AB, you can easily say the answer is C. That means angle B is the opposite side of AC, angle C is the opposite side of AB. Now the point is, if AB and AC are equal, means if two sides AB and AC of this triangle are equal, then what will be the relation between angle C and angle B? We have never read. Okay, so what will be the relation between the two opposite angles of two sides which are equal? Means if two sides are equal, what will be the relation between their opposite angles? Let us investigate. Actually, the proof of this statement is there in another chapter known as congruency. It will be discussed. The proof will be discussed there. We have to at present just remember. What is that? You see, if AB equal to AC, see, if any two sides, if AB equal to AC, look at, in this figure, we have taken AB equal to AC. So the opposite angle of AB is C, then angle C will be equal to, angle C is the opposite angle of AB and angle B is the opposite angle of side AC. So angle C will be equal to B, you see. So what I mean to say children, in isosceles triangle, if two sides are equal, then their opposite angles will be also equal, okay. In isosceles triangle, you can take any two sides as equal. If any two sides of isosceles triangle are equal, then their opposite angles will automatically be equal. So how to prove it, we will discuss in another chapter known as your congruency or congruent triangles, okay. There we will discuss the geometrical proof of this truth, okay. So at present, we have to remember that what is isosceles triangle? The length of any two sides must be same. It is isosceles. And what I said, if any two sides equal, then their opposite angles will be equal. Okay, let us discuss something more about isosceles triangle. See children, now these two are equal. So we say these are equal sides. See, AB and AC are the equal sides. Then which is the unequal side? This is the unequal side. So this unequal side is known as base. You see, the unequal side of isosceles triangle is called the base, okay. And if BC is the base, look at, if BC is the base, look at angle B and angle C. These two angles, they stand on the base, okay. So as these two angles stand on the base, So we call angle B and angle C and angle C as base angles. You see, this is the base of this isosceles triangle. Why? Because it is the unequal side. The unequal side of isosceles triangle is called the base. And on the base, how many angles lie? 2 angles. Those 2 angles which lie on the base, they are called base angles. Then if angle B and C are base angles, then what about this angle? What about this angle, angle A? Look at. What will we call angle A? Angle A is called vertical angle. It is called vertical angle or vertex angle, whatever you say. See, so in isosceles triangle there are how many base angles? 2 base angles. How many vertical angle? 1 vertical angle. Which is the base? The unequal side is the base, and the 2 angles which lie on the base or the unequal side, what are they called? They are called base angles. And what is the relation between the 2 base angles of an isosceles triangle? Just I discussed here. The 2 base angles of an isosceles triangle will always be equal, because in isosceles triangle if 2 sides are equal, then their opposite angles are equal. We have to assume this as a truth at present, whose geometrical proof we will discuss in another chapter known as your congruent triangles. Okay, towards the end of your all the chapters it is given, we shall discuss later. Okay, so this is all about isosceles triangle, and you can say this is the property, this is one of the properties of isosceles triangle, that in an isosceles triangle the 2 base angles are always same, or angles opposite to the equal sides of an isosceles triangle are same or equal. Okay, so this is called, this is one of the properties of isosceles triangle. Okay, now let me discuss about exterior angle, interior opposite angle, interior adjacent angles. This was there in class 6. Let us see whether you have remembered or not. Okay, let me discuss about exterior angle and interior angle. See children, what is exterior angle? Exterior angle. See, exterior angle. What is exterior angle? Look at, suppose ABC is a triangle. Draw any triangle ABC. As you know, there are 3 sides. These angles are interior angles. See, these are interior angles, 3 interior angles. Okay. Now, what is exterior angle? To get an exterior angle, it was there in class 6. You just produce any one side. Suppose you see, you produce means extend. You extend the side BC, suppose up to D. Let us extend the side BC up to D. If we extend the side BC up to D, look at the vertex C, look at the vertex C outside the triangle, an angle has been formed. So this angle is called this is an exterior angle. See, so what is the name of this exterior angle? Exterior angle is your angle ACD. See, the name of this exterior angle is angle ACD. This is an exterior angle. So what is an exterior angle? An angle formed by extending or producing any one side is called exterior. Okay. Now the point is, how many exterior angles we can find or get in a triangle? Definitely 3, because you see there are 3 sides. So all the 3 sides can be extended in 3 different directions. So definitely there will be how many exterior angles? Like there are 3 interior angles, interior angle A, interior B, interior C. Similarly, there will be 3 exterior angles. So now let us consider about this exterior angle. So this exterior angle has been obtained. How? By producing or extending BC up to D. Okay. Now the point is, see children, when we obtain or when we get this exterior angle, you see, before we had produced the side BC, there were how many interior angles? 3, namely angle A, angle B and angle C. Now when we produced or extended BC up to D, see, what we call this angle? This angle, your ACD, what will be the name of this angle? And what will be the name of angle BAC, and BAC means this angle, and ABC and angle ABC. See children, what I want to ask you, when we had not produced or extended the side BC, we had only how many angles? 3 interior angles. But when we produced or extended the side BC up to D, here we got an exterior angle. So when we got this exterior angle, now these are the 3 angles. So what special names do these 3 angles have? Let us discuss. See, when this is the exterior angle, these 2 angles, that is angle A and angle B, they are not called interior angles. Please remember, try to understand. When this is exterior, these two are not interior, then what are they? See, when this is not exterior, when there is no exterior, no doubt these two are interior. Even this one is interior. But when this is an exterior angle, these two are not said to be interior angles. Then what are they called? They are said interior opposite. Please remember, this was there in class 6. I don't know to what extent you have remembered. Interior opposite. You see angles. See children, angle A and angle B are called interior opposite angles when we consider this as an exterior angle. Angle ACD, when angle ACD is exterior, these two are not interior, they are interior opposite. Similarly, angle ACD, it is also not interior. It is what? It is interior adjacent. The concept of interior adjacent and interior opposite angle was there in class 6. I do not know whether you have remembered or not. Okay, let us review. So, what is exterior angle, children? Let me summarize once again. In a triangle, if we produce any side, if we extend any side, okay, the angle formed at the vertex where we produce the side is known as an exterior angle. And when this is an exterior angle, suppose angle ACD, then angle A and B, they are not interior. They are called what angles? They are called interior opposite angles. And look at the interior angle, this one, C. So, when this is exterior angle C, that is angle ACD, not C, don't say C, don't say angle C, say angle ACD. Because if you say C, if you say only angle C, there are three angles, namely angle ACD, angle ACD, angle ACB and angle BCD, which is a straight angle. So, there are three angles at the vertex C. So, never say angle C, name the angle in full, okay, give the complete name of the angle. So, when ACD is exterior angle, angle ACB is not interior. What we call it? We call it interior adjacent. So, see children, one thing I would like to say here. When the concept of exterior angle comes, this exterior angle has how many interior opposite angles? 2. And how many interior adjacent? 1. Which are the two interior opposite angles? Angle A and angle B. When this is the exterior angle. When angle ACD is exterior, these two are interior opposite. And angle ACB is what? Interior adjacent. Okay. So, we can say that every exterior angle has two interior opposite angles and one interior adjacent angle. Let me make this point more clear. See, suppose let us let us produce in this side. Suppose A, B, C. Now see, this is an exterior angle. When this is exterior, look at, when this is exterior angle ABD, so these two, angle A and angle C, when this is the exterior, these two will be interior opposite and this will be the interior adjacent. Okay. So here in this case, when this is exterior, these two are interior opposite and this is the interior adjacent. Here you see, we have produced CB in this direction up to D. So this is one exterior. So when this is exterior angle, angle C and angle A are interior interior opposite. They are interior opposite angles. And this is what angle? Interior adjacent. Now let me change another one. Suppose you see, let us see, let us produce it in this direction. Let us produce A, B, C. Let us produce CA up to D. See, suppose produce or extend the side CA up to D. Now look at this angle. This is an exterior angle. What is the name of this angle? Angle DAB or angle BAD. Angle BAD is exterior. Then which will be interior opposite? This. Look at these two angles. These two angles are what? Interior opposite angles. And this angle, angle BAC, it will be interior adjacent. So in all the three cases, see, in all the three cases, case 1, case 2, case 3, what did we see? We saw that when we extend any one side of a triangle, we are getting one exterior angle. And when we are getting one exterior angle, it will have how many maximum interior opposite angles? 2. And it will have how many interior adjacent angles? 1. Okay. So every exterior angle which is formed by extending or producing one side of a triangle has two interior opposite angles and one interior adjacent angles. Now the point is, what will be the relation between an exterior angle and the two interior opposite angles? Again, what will be the relation between an exterior angle and interior adjacent angles? Okay, let us discuss. Actually, the proof of all this, it is beyond the course. It will be taught in class 9 only. The proof of all this we shall find in class 9, the geometrical proof of this. Just at present, we have to remember the concept, we have to remember the relations, and we have to apply it in problems. Okay, in class 7. Now see, when this is exterior, these two are what I said, they are interior opposite. So what will be the relation between this angle and these two angles? Children, you will be surprised, you will be astonished to know that this exterior angle is equal to the sum of these two. That means, if this is, suppose you see, suppose this is 50 degree and this is 80 degree. If you measure this, it will be 130 degree. You can easily verify, children. You draw any triangle, you can easily verify it. You draw a triangle, produce any one side, you will get an exterior angle. Measure this angle with the help of protractor by experimental method. Measure this angle with protractor. Then measure these two interior opposite angles with protractor. You will find that the sum of these two will be equal to this. That means exterior angle of a triangle is always equal to sum of the interior opposite angles. Okay, this is the relation between an exterior angle and its two interior opposite angles. As I told you, every exterior angle has only two interior opposite angles. So the exterior angle will be equal to the sum of the two interior opposite angles always in a triangle. Its proof you can do by experimental method. Draw any triangle, produce any one side, measure the exterior angle, and find the measure of the two interior opposite angles with protractor. You add them, you will get, it will be definitely equal to the measure of the exterior angle. So from this we can say that an exterior angle is always equal to the sum of its interior opposite angles in any triangle. It is true. Okay, its geometrical proof we will discuss in class 9. Now see, now if this angle is equal to, that means what I want to say, children, angle ACD, you see what I want to say, I want to say that angle, exterior angle ACD in this figure will be equal to angle A plus angle B, because these two are interior opposite and this is exterior. Okay, now if this angle is equal to sum of these two, definitely this angle is greater than this and this. That means the exterior angle will be greater than each of its interior opposite angles. It is obvious. If you see, if 10 equal to 7 plus 3, then definitely 10 is greater than 7 and 10 is also greater than 3. Okay, similar is the case. If angle ACD equal to angle A plus angle B, then this exterior angle ACD will be definitely greater than angle A as well as greater than angle B. Okay, now the last part of this, now see, we came to know what is the relation between exterior and its interior opposite angles. Now the point is, what will be the relation between an exterior angle and its interior adjacent angle? As I told you, every exterior angle has one interior adjacent but two interior opposite. We came to know what is the relation between exterior angle and the two interior opposite angles. But let us find out what is the relation between this angle and this angle. It is very clear, children. You know what is linear pair, already we have read in class 6. Linear pair, this angle and this angle, they form a linear pair. Why? Because these two angles have a common vertex. Look at this angle and this angle have a common vertex C, and which is the common arm CA. CA is the common arm of this angle and this angle. C is the common vertex of this angle and this angle. And what about the non-common arms? The non-common arms CD and CB, they lie on a straight line. So that is why these two angles form a linear pair. So two angles are said to form a linear pair if they have a common vertex, that is C, if they have a common arm, that is CA, and the non-common arms CB and CD, they lie on one straight line. So that is the reason why these two angles form a linear pair. And you know, when two angles form a linear pair, their sum will be how many degree? Definitely 180 degree. Two angles forming a linear pair, the sum will be equal to 180. It can never be less than 180 or more than 180. So we can say that angle, exterior angle, we can say that exterior angle ACD plus angle ACB, this is interior adjacent, will be equal to 180 degree. This is the relation. This is the relation between an exterior angle and its interior adjacent. Their sum is always 180 because they form a linear pair. And the relation between exterior angle and its interior opposite is what? Exterior angle is equal to sum of its interior opposite angles always, and each exterior angle is greater than each of its interior opposite angles. Okay. So with this we almost completed everything about properties of isosceles triangle and what is exterior angle, the concept of exterior, interior, interior opposite, interior adjacent, everything. So we will discuss more about this in the next class. Children, I hope whatever I discussed you must have understood. If it is really so, then I would like to say please hit the like button and subscribe my channel so that I will be happy and encouraged to discuss more and more things again in my upcoming classes or videos. Okay, good day.